Good morning, everyone, and welcome to Ohio EPA's NPDES Construction Stormwater presentation. My name is Dan Sowery with the Division of Environmental and Financial Assistance here at Ohio EPA, and I'll be moderating this morning's presentation with Ohio EPA's Wes Sluga. We also have Ohio EPA subject matter experts behind the scenes helping to address submitted questions. And with that, I'm going to turn it over to Ohio EPA's Wes Sluga.
Thank you all for being here as well. Today, I'm going to give a presentation on the overview of the National Pollutant Discharge Elimination System, or NPDES, Construction Stormwater Program in Ohio. In this webinar, you will learn basic but crucial information about Ohio's construction stormwater program, such as where and when construction general permit coverage is required, how the NOI and NOT application process works, and what is expected of the applicant, what information is needed within a stormwater pollution prevention plan, and the most important active and post-construction requirements. We're going to start with a poll. And the poll question is, working conditions have certainly changed for many during the pandemic. What is your current status? At home, in the office, or hybrid? All right, we've got a pretty healthy mix. About half of us are in the office, with about a third of us at home. I'm one of those. I'm currently at home. I haven't been in the office for more than a year now, but that's all right. We've all been able to get our work done. So I'm really glad that you are attending no matter where your location is. So we're going to start today with a quick background. And what I want to say is that the permit, or the construction general permit, is the foundation for Ohio's construction stormwater program. So understanding the permit is the key to understanding the entire program. This permitting program is mandated in the Clean Water Act and is part of the NPDES program. The construction general permit got its start back in the early 1990s, which is before I was even born, but or so I've heard. So as you can see, the permit has evolved over time. It's become more refined as we've gained a better understanding of how best to protect our water resources, like lakes and streams. At some points in the permit history, big changes were introduced, like in 2003, when post-construction controls were required for the first time, and all sites over 1 acre needed coverage. Other times, minimal changes were made, and the permit largely rolled over from its previous state, like in 2008 to 2013. And currently, we're in the 5th edition of the CGP, and we'll see a 6th edition of the permit come out in a couple of years. Before really getting into the specifics of the permit and the construction stormwater program, it's very important to understand why the permit exists. And that reason can really be boiled down to pollution. And typically, we view pollution as man-made chemicals that are being released into the air or water, but pollution really has a much broader definition. Now, this isn't to say that man-made chemicals aren't a concern with construction sites, because they certainly are, and I will discuss them later in some more detail. But the permit was enacted to control and limit the various kinds of pollutants that are associated with construction activities. And this permit is issued and overseen by the Division of Surface Water, which means the impacts are largely focused on impacts to water and water quality. Construction sites contain many different pollutants that can easily be made mobile through stormwater runoff. And so the permit issues criteria for that discharge of the runoff, both during and after the construction process. During the active construction phase, impacts to our water largely come in the form of sediment pollution. Bare, exposed soil is easily eroded by rainwater, especially when it becomes concentrated. Moving water is an incredibly powerful force, and it can gradually strip loose sediment like sand, silt, clay, and even rocks, and then carry it away. You can easily see this with your eyes, as flowing water in streams after a storm event is often cloudy or brown like chocolate milk there in the bottom picture, which means that it's laden with sediment. And sediment is the leading cause of impairment to Ohio's rivers, streams, and lakes. And it's also closely associated with the addition of excess nutrients, and which can lead to the algal blooms that we've all seen or heard about in the news. As the sediment is transported into streams and lakes, it eventually gets dropped or deposited, and the bottoms of those waterways become covered in fine particles. And this results in what is called an embedded stream, where the channel no longer has space in its bed for small organisms to live, and the ability of the channel to let water flow is reduced. This loss of habitat and capacity is detrimental to Ohio's streams and rivers, and thus the CGP requires certain controls to be put in place to try and minimize some of those impacts. However, the problems don't necessarily stop once construction is complete. Often, development means a new building or parking lot is being installed, and these man-made surfaces are impervious, meaning water cannot infiltrate into the soil below. Instead of some of that rainwater recharging into the groundwater system like it naturally would, all of that stormwater runs off and enters the stream, and natural stream systems just aren't used to that. The added water is going to flow faster and higher with more energy, which cuts away at the banks and the bed, and it pulls sediment with it. This stream erosion leads to the same problems I just discussed on the previous slide. Unfortunately, development also means that human activities are more frequent in the watershed, and thus more pollutants, like those chemicals I talked about, or heavy metals, gas, or oil, can more easily enter the stream after being washed off the pavement. And this is why the CGP also requires controls to be in place after the construction has been completed. So hopefully you all have a better understanding of why the permit exists, but now we need to talk about how the permit works, starting with which activities are covered under an NPDES construction general permit like the one we have here in Ohio. And the permit requires that construction activities over 1 acre must be covered. And the permit defines construction activities to be clearing, grubbing, grading, excavating, and or filling. Clearing is the removal of surface vegetation like trees or bushes, while grubbing is the removal of features that have been embedded in the soil like roots and rocks. Grading is the shaping and contouring of soil, while excavation is digging, and filling is the addition or dumping of material on site. So essentially, anytime soil is exposed and unstabilized, CGP coverage must be obtained. But the size of these activities also play a part in coverage. The permit requires all sites over a single acre of disturbance to be covered. And the key word there is disturbance, because a site could be 10 acres, for example, but if less than an acre of that 10 acres is being disturbed, then you're not going to need CGP coverage. Another important note is that this coverage applies to projects that are part of a common plan of development, which means that, say, our imaginary 10-acre site can't evade permit coverage by dividing the property up into 20 half-acre lots and then starting grading and excavation on each of those. Additionally, any associated activities to the construction process that are close by are included in the disturbance area. That would be like borrow pits or material storage areas. All right, so now we know which activities need CGP coverage, but how and when is that coverage obtained? Well, nowadays, the how is much easier than it used to be. After developing a stormwater pollution prevention plan, or SWIP, for your site, all you need to do is go online to Ohio EPA's e-Business Center and apply for coverage using a Notice of Intent, NOI, which is a form that indicates you want coverage under the CGP. Then, after getting your permit approved, you need to adhere to the conditions listed in the permit to maintain your coverage. For the when, you must develop that SWIP prior to NOI submittal. And if you fall in an urban area, for example, it may require that you get your plan approved by the local regulators first. Then you'll need to make sure that your NOI is submitted at least 21 days prior to the construction start date, as this gives a buffer to make sure that everything is good to go and the project is permittable. Then, if the project is going to be divided, like a residential subdivision, for example, each individual lot must get coverage by submitting an individual lot NOI at least 7 days prior to transfer of ownership. Thus, the responsibility to adhere to the permit conditions is passed on to the new owners. So we know what sites get coverage and how and when that coverage is obtained, but specifically who needs to apply for coverage, i.e. whose ultimate responsibility is it to be covered, and what does that coverage allow? The CGP requires that the operator submit the NOI to obtain coverage. And an operator is simply the party who has day-to-day control over the operations on site. Or it could be the owner or overseer of the site from which the day-to-day manager gets authorization from. And it's entirely possible that there could be more than one operator for a single project. In that case, each operator is required to obtain coverage as a co-permittee. And this is commonly missed in many projects all across the state. And as I mentioned on the previous slide, when the project is subdivided and ownership is transferred, the new owner would use that individual lot NOI process to obtain coverage. Now, what the CGP provides coverage for is the discharge of stormwater, specifically stormwater runoff associated with construction activities into a water of the state, like a lake, river, or stream. That stormwater runoff must be treated appropriately by using practices and methods to minimize pollution transport. There is a list of prohibited discharges that are not covered under the permit, and they include like concrete wash water or construction wastewater or construction waste materials, fuel and oil from vehicles, soaps or solvents from vehicle washing, and any uncontrolled dewatering. The permit does not allow for these items to be discharged. Instead, they need to be contained and disposed of properly. So the CGP is a statewide permit for all of Ohio and thus covers construction activities in every county throughout the state, urban or rural. There are some special conditions, though, that apply for two specific watersheds that are protected beyond the rest of the state. And these watersheds are for the Big Darby Creek and for portions of the Olentangy River, as you can see in the graphic here. They're protected because of their significant environmental and ecological value. For example, the Big Darby Creek is one of the most biologically diverse streams of its size in the entire United States. And it's found right here in Ohio, which is pretty cool. In these watersheds, all of the normal permit requirements apply, but there are some added ones. For example, the SWIPs for these projects that occur here must be submitted directly to the Ohio EPA, and they will be reviewed prior to receiving coverage. Additionally, there are stream setbacks that apply in both of these watersheds, and they discourage development right up to the stream bank. In the Big Darby Creek watershed alone, a groundwater recharge volume requirement exists, as well as a larger dewatering volume for any sediment basins that go in there. As I mentioned, the online NOI application process isn't very complicated, and it's honestly become quite streamlined now that it's entirely electronic. The form allows for someone other than the operator to fill it out. That'd be usually like a consultant, but it must be submitted by the operator. Thus, an operator and a consultant would need to each make an account, which is pretty simple. And there's lots of step-by-step guidance on how to do that on the page. Once logged in, they would need to fill out the form completely, entering information about the project location and providing a site location map that's accurate. Also, some other things that are included in this form are the size of the disturbance, the operator contact information, just to name a few. But remember, before submitting an NOI, a SWIP must be developed for the project. Well, what is a SWIP? First and foremost, a SWIP is a broad communication tool that details how stormwater pollution is going to be controlled on site. And it can be kind of hard to define because there are many different things that need to be communicated to many different folks. For example, the SWIP needs to tell the contractor exactly where and how to install a sediment basin, but it also needs to include the information that an engineering consultant used to properly size the outlets for that sediment basin. So some may describe a SWIP as a communicated thought process that identifies and describes where the pollution concerns are on site and what is the best way to prevent them. And remember, the first set of plans might not work, so there needs to be a backup that are readily available in case something fails. Therefore, it's critical that the SWIP be specific and doable. It needs to set the contractor up for success. This means maybe that costs and expectations have already been identified up front, and who is responsible for what, so that responsibility isn't an issue down the road when activities are already underway. As a result, a SWIP tends to be a pretty unique document. It's more than just plan sheets or drawings included in the overall set of construction plans. It's multimedia, as it involves many different components like narrative and drawings, calculations, maps. And it really should be this all-inclusive plan to combat stormwater pollution that can be easily understood and recognized by every single person on the construction site. Things are apt to change in the field, so it does need to be a living, breathing document that can adapt to changing circumstances rather quickly. It is very important to drive home that a SWIP corresponds to a specific NOI and not a specific parcel. So what that means is the NOI only authorizes the specific construction activities depicted in the SWIP. So for example, multi-phase projects like large subdivisions must have a new NOI be submitted for each different phase of the project, and a corresponding SWIP will need to be developed for each one of those phases. As I mentioned before, the SWIP must be fully developed before the NOI submittal, and it needs to be kept on site and available during normal working hours. If it's requested by the Ohio EPA or a local regulator, like a soil and water conservation district, then the SWIP needs to be made available within 10 days of the request. Lastly, if the SWIP is found to be deficient in some manner, it needs to be corrected within 10 days of being alerted to the deficiency. Ultimately, the SWIP is one of the core components on how to meet the CGP requirements. And there just isn't enough time to go line by line and discuss all the detailed requirements of a SWIP. Instead, what I can do is say that the 19 pages from page 13 to 32 in the Construction General Permit, Part 3G, clearly spells out each of these requirements. But remember, the general permit has to cover every single different kind of construction project across the whole state and what might come into play on each of those sites. For example, contaminated soils which doesn't apply very often, but when it does, addressing it appropriately is vitally important. So operators and consultants should do their best to familiarize themselves with the requirements in the permit, and that's really best done by reading through it. However, the Ohio EPA does have a SWIP checklist that can be used as an aid in reviewing the requirements of a SWIP. So what I'll go into next is what a SWIP does. And for a site, or for a single phase of a site, it is the guide, it's the game plan, it's the instructions for dealing with stormwater pollution. And the primary method to addressing that pollution is by prescribing controls. And these controls are broken down into a handful of different categories, and they generally include preservation controls, erosion controls, sediment controls, runoff controls, and pollutant controls. Each play an important part in controlling stormwater pollution and need to be used together to be most effective. But what does that really look like? And perhaps the best place to start is with a pre-construction map. So with this tributary map I have here. And before I really know anything about the project, I can quickly assess what would be needed for the active construction phase. So the SWIP must identify where pollutants can escape and how best to prevent that and treat them when they do get mobilized. So for example, looking at this document, you can see down in the right-hand corner, maybe that's the construction entrance. That's where access is going to come in and out of the site. On the southwest corner there's a sediment basin because it might be a low spot. So a diversion ditch that's filled with rock check dams can bring stormwater down to that sediment basin. You can see with the dark dashed black line that there are multiple watersheds within this basin, different drainage areas. So that small corner there to the west might need its own sediment basin and its own diversion ditch because the water is going to be draining in a different direction. Now, some areas are small enough that they don't really need a sediment basin. So, for example, in the middle, sediment barrier like silt fence could be effective to managing that runoff. And lastly, there to the north, stormwater runoff doesn't listen to project boundaries. It's simply going to flow where the topography dictates it will. So off-site run-on is something that needs to be considered in all projects and treated just like it fell within the disturbed area of your own project. So some of the components of a SWIP are very vital, while others might not be. For example, every single SWIP should contain water quality volume and sediment basin sizing calculations, as well as post-construction operation and maintenance plans, drainage maps, all of the sediment runoff and erosion control drawings, and any pollutant control procedures. However, some things that a SWIP doesn't need to contain would be a copy of the construction general permit, nor hundreds of pages of peak flow hydrographs. Some other excessive material that I've personally seen include an entire copy of the Rainwater and Land Development Manual at almost 500 pages. Things like that don't really do much other than bog down the entire SWIP, and it makes it harder for on-site staff to familiarize themselves with such an enormous document. And it makes it harder for the reviewer to make sure that everything's in order. When the middle category there, maybe in a SWIP, items are only considered to be maybe because the conditions for which they apply are not universal. It does not mean that they can be excluded if those conditions apply. For example, if the site is going to fill isolated wetlands or get a nationwide permit from the U.S. Army Corps of Engineers, then 401 and 404 authorizations are not optional, and they must be included. But like I said, not all sites have that. So now we've covered what a SWIP is and what it must contain. So let's talk about the review objectives. Now, clearly, the main reason a SWIP gets reviewed at the local and sometimes at the state level is to ensure compliance with the CGP. And a quality review of a SWIP should help to fix issues on the front end where it's easier and cheaper to do. It should create a relationship between all the parties that are involved with the project, and it hopefully will start a positive relationship where parties can work together. It also creates learning opportunities for everyone involved, and it's a chance for developers, consultants, and contractors to work on how their actions affect the issues that are important to both pollution prevention and to the community. Another part of the permit requirements are the non-numeric effluent guidelines, which are really just a fancy way of saying less quantifiable, or largely no numbers are associated with these guidelines. These guidelines direct that erosion and sediment controls be used to minimize erosion of the soil, erosion in streams, or at the outlets of any basins. These controls should be used to minimize disturbance on steep slopes, because slopes like that are prone to rapid erosion. Also, special care should be taken to minimize soil compaction, because it significantly impacts the ability of the soil to infiltrate water, and it can act more like impervious surface than natural soil. 50-foot buffers should be used whenever possible on site around any water areas, because the closer disturbance is to a stream, for example, the easier it is for pollutants to enter it. Stabilization is another key focus area for the permit, and is one of the only number-centric requirements of this section. Any area that is disturbed and won't be touched for 14 days, or has reached final grade, or is going to overwinter in that condition, needs to be stabilized as soon as possible. If that disturbance occurs within 50 feet of a stream, it must occur within 2 days, where everywhere else there's a maximum of 7 days to stabilize. If the lot is being transferred to another owner, then it must be stabilized 7 days prior to that transfer of power. So these non-numeric guidelines continue and include proper dewatering practices. So when water collects below ground in pits or trenches, it needs to be pumped out, or i.e. dewatered. And the permit briefly describes how to do this, but the Rainwater and Land Development Manual goes deeper into the topic. And the general idea is to prevent that pumped water flows over disturbed soil and then picks up sediment. So instead, the hoses should direct water into well-stabilized grassy areas instead. Pollution prevention measures are also very important, because just like the graphic says, what goes into the storm sewer ends up in our water, like the lakes and rivers where we swim and boat. Therefore, activities like vehicle washing that create water laden with soaps and solvents, or vehicle fueling where oil and gas can spill, needs to be contained. So precautions should be taken to minimize those spills and leaks, and a procedure needs to be developed that includes contacting the spill hotline, and that should be posted around the site and included within the SWIP. During the active construction phase, there are 3 main types of controls that can be installed to combat sediment and erosion pollution. So starting with erosion controls, these are the controls that act at the source of the runoff. Anywhere rain falls on a site, a source erosion control could be put in place, and they act to prevent sediment from being transported along with the runoff. And they are by far the most effective of the 3 controls. And when installed properly, can be more than 90% effective at controlling erosion from sheet flow. However, at a maximum of about 300 feet, sheet flow will become concentrated flow, and erosion controls aren't going to work as well there. Instead, runoff controls work there to slow down the runoff and convey it to a sediment control. And sediment controls are the collection or the treatment controls, which work by filtering or settling of sediment that's been suspended in the runoff. They're much less effective than erosion controls, and they really should be the last line of defense. So examples of each type of control is listed here. So erosion controls like vegetated stabilization or phase disturbance really act at the source, and runoff controls like rock check dams slow down runoff after it's been concentrated. Sediment controls may be the ones that are most recognizable, like silt fence or inlet controls or sediment basins, but we know that they are the least effective, so they shouldn't be used all by themselves. The goal for these practices is to keep water clean all the way to the stream. They should be used together in a multi-step fashion where one practice leads to another to maximize effectiveness. So they should follow water from the source all the way to the outlet to the stream. And we call that a treatment train. And you can see in the graphics that maybe on the plan sheet there on the left, the flat areas that have been disturbed should be quickly stabilized. And then you could see a diversion ditch that kind of snakes down into a sediment basin before it ultimately outlets to a stream. Or like the picture there of the dewatering, the hoses are bringing that water across the disturbed soil and outletting it onto the stabilized green grass. So with all of these different practices, how can we ensure that everything is working the way it's supposed to? Inspections. The site must be inspected by the permittee once every 7 days within 24 hours of a rainfall event. Now, of course, if it rains on a Saturday and no one works on Sunday, then that isn't as much of a concern. Just as soon as possible in that case. The specific areas on a site that should be the priority for inspections include the perimeter, as that's where sediment is going to leave the site, any access points to check if sediment is being tracked out, material or waste storage areas, as well as the fueling areas, as they be the areas where pollutants can quickly mobilize. Additionally, any areas where BMPs are located to check to see that they've been installed correctly and are still functioning as designed. And lastly, any area that contains surface waters like lakes, rivers, or streams, because remember, that's all that we are trying to protect with this permit. Now, when inspections come back with reports that a practice is missing or wasn't installed properly or isn't functioning right, there are timeframes on how quickly that correction must take place. And the table outlines these requirements. Sediment barriers and erosion controls needing the fastest attention at 3 days. And then it's 10 days for all the other findings like missing BMPs or sediment basins that aren't performing as intended. Now let's jump over to post-construction. And so we've assumed that active construction has concluded, and the primary requirement of the CGP is to treat the water quality volume, the WQV, for the development. And this volume must be captured and treated either through extended detention or infiltration. It's sized using equation 1, which multiplies a 0.9-inch precipitation event by the R sub V, which is just the runoff coefficient, or that's really the percentage of the precipitation that runs off. And it's a function of impervious area, as you can see there. Then you multiply that by the area draining to the practice, as water quality volume is treated by practices and therefore must be calculated for each practice's drainage area. The entire site will have its own water quality volume, but it can be broken up and treated by multiple practices. Now, are there any exceptions to the water quality volume requirements I just laid out on the previous slide? Yes. For example, projects that do not create any impervious surface are exempt from supplying water quality volume. Also, if the project is linear in nature, like a road or trail, there's some flexibility that's allowed so that in addition to the Rainwater and Land Development Manual, designers can utilize the practices and methods described in ODOT's location and design manual. And if a project is considered to be small, which is greater than 1 acre but less than 2 acres, there are practices that are available to address water quality volume that are a bit more flexible. So some standard practices or designs may be infeasible on such small sites because of size constraints. So if a designer can provide justification that to the Ohio EPA that another method may be better suited for that specific site, then it will be judged and approved on a case-by-case basis. Other exceptions include credits for the redevelopment and runoff reduction practices. So for the first one, a site that is replacing existing impervious area as opposed to developing new impervious area is preferable. So a credit towards the WQV is applied. Or if a project is going to use a runoff reduction practices that promote infiltration, like grass filter strips and downspout disconnections, then a credit towards the water quality volume will also be applied. And these credits are all detailed much more in the Rainwater and Land Development Manual. It appears it's time for another poll. So Ohio EPA's program uses many different acronyms. Which of the following isn't an acronym associated with construction storm water? WQV, NPDES, UFO, or SWP3? Oh, so close to perfect. Very good. We know that unidentified flying objects are probably not a primary concern of Ohio EPA's construction storm water program. Nice job, everybody. All right, let's get back into it. So there are a variety of practices that can be used to collect and treat the water quality volume. Some of the most common are the extended detention practices. And these practices capture and temporarily detain the water quality volume by letting it drain out slowly over a day or two, which is why they're called extended detention. Some of these are immediately recognizable, like the wet basin with its large permanent pool of water, or the dry basin, which is a little bit of a misnomer because it does need to have a small forebay at each inlet and a micro pool at the outlet that hold water all the time. Other examples include the wetland basin, which is a great way to mimic wetland hydrology and habitat, or underground detention systems with some kind of pre-treatment. These underground systems work well when surface space is limited, but they tend to be a little bit more pricey than the other options. They also need some way of filtering out large particles before stormwater enters the system because they are much more difficult to clean out than the others. As I mentioned, extended detention works by draining the water quality volume over an extended period of time, and each practice has a specific minimum drain time optimized for its treatment performance. So wetland and underground basins cannot drain the water quality volume in less than 24 hours, and dry basins can't in under 48 hours. And the way to measure this is by using equations or software that calculate the drawdown by pulling an imaginary plug from a full basin and measuring the outflow, which is referred to technically as a static drawdown with zero inflow. Additionally, there is a stipulation that says no more than 1/2 of the water quality volume can leave the basin in the first third of that minimum drawdown for the practice. And that prevents basins from having outlets that draw stormwater out really quickly at first, and then it just dribbles out at a trickle after that. So let's look at an example of a dry basin with a water quality volume of 9,000 cubic feet. This graphic that you can see here is pulled right from the BMP compliance spreadsheet tool, which was put together by us at the Ohio EPA, and it automatically calculates many compliance checks for these post-construction practices, including drawdown for you. And even better, it's available online for everyone to see. And I'll say a little bit later where we can access that. And as you can see, the drawdown curve shows that water quality volume drains in more than 48 hours. It is a dry basin, so that checks out. And then half of the water quality volume, 4,500 cubic feet, which is half of 9,000, drains in more than 16 hours, which is a third of 48. And so this basin looks good to go for its water quality volume drawdown. However, extended detention isn't the only way to meet the water quality volume requirement, as I mentioned. Infiltration practices can collect the water quality volume and allow it to percolate into the ground, which mimics nature even more than extended detention does. And these practices do require some specific soil conditions that must be determined by testing, like infiltration rates must be more than a ½ inch per hour. Additionally, infiltration practices are susceptible to clogging from fine particles, so they must be designed with adequate pretreatment and size so that they don't get overwhelmed by the contributing drainage area. Some examples of these practices include infiltration basins or infiltration trenches. Other infiltration practices include those that typically would be described as green infrastructure, like porous pavement that are used in parking lots, or bioretention basins filled with native plantings. Runoff reduction practices also fall in this category, like grass swales that are a great eco-friendly alternative to traditional storm sewers in some cases. Another type includes sand filters, which are commonly seen near airports because they don't have any ponded surface water that attract waterfowl, because birds and planes don't really mix very well. So it can seem a bit overwhelming with all of the practices that I just breezed right through. There are so many different options. Each one needs to be designed so specifically. Luckily, the Rainwater and Land Development Manual is there to provide guidance for almost all things stormwater, especially design standards. This manual is chock full of helpful information to ensure that each practice is designed properly. There's a link there, but I'll talk more about how to get to it a little bit later. Sometimes, though, water quality volume just isn't feasible to be dealt with on-site. In that case, off-site mitigation is an option that can be used. The Ohio EPA reviews and approves these requests on a case-by-case basis, but each one must at least contain a comprehensive maintenance agreement. It must be nearby in the same HUC 12 watershed, and must provide more water quality volume than it would have on the original site, at least 50% more for a 1.5-to-1 ratio. And this mitigation is honestly best done on older sites that were developed before the CGP, and thus the existing peak flow or flood control basins there may be an ideal opportunity to provide water quality volume mitigation through a retrofit without having to construct a whole new basin. So as we get close to wrapping up this presentation, I want to talk about what to do when the active construction process starts to wrap up, which is to submit a notice of termination, or an NOT. The most important thing to do before submitting an NOT is to make sure that there is a long-term post-construction operation and maintenance plan in place. Without one, all of the hard work that was put into designing, installing, inspecting, and maintaining those stormwater management practices would all go to waste. So the O&M plan is vital to ensuring that the practices function as intended for the foreseeable future. Once that is done, then an NOT needs to be submitted, which is also online, just like the NOI. To qualify for an NOT, the site must either be permanently stabilized, which means it has grass vigorously growing and there's no bare soil exposed, or coverage under the CGP needs to be transferred to another operator. With one of those two conditions being met, you can submit an NOT within 45 days of completion, and coverage under the CGP is closed. We've covered a lot of material today, but I want to rehash the most important points from the presentation. So first, we can see that the CGP exists to protect our rivers, lakes, and streams by regulating construction activities during their active phase and after construction is complete. We know that construction activities over 1 acre need coverage under the CGP, and that an operator obtains that coverage by applying for an NOI online through the eBiz Center. Sediment is the major pollutant in Ohio, and the best management practices are needed to design to minimize its release in our waterways. The plan to implement those practices come in the SWIP, and that SWIP must be completed before the NOI is submitted. The SWIP needs to be specific and directive, as it's the key to setting the contractor up for success on site. The SWIP should explain in detail how to implement a treatment train of necessary controls that will keep water clean all the way to the stream. Bare areas with exposed soil are the most prone to erosion, so quickly seeding or stabilizing them is vital. And we know that without frequent and thorough inspections, practices can fail to work as intended. And even those that are working will need maintenance to keep them operational. And this is just as important during the construction process as it is after. Once construction is complete, stabilize the site or transfer coverage to another operator and apply for an NOT. Then from then on, the site will serve its developed purpose, and the extended detention or infiltration practice installed will continue to capture and treat the water quality volume, which helps to keep our streams, rivers, and lakes healthy into the future. And if you have any questions or concerns, don't hesitate to reach out to the Ohio EPA, because we are here to help you in whatever way we can. So what if you want to explore more on your own? Well, step one is to navigate to the Ohio EPA's Stormwater Program webpage. This can be done by going to epa.ohio.gov/DSW/storm/index, or searching for the Ohio EPA Stormwater Program online. Once on the page, you'll need to scroll down until you can see the tabs. For the materials related to the construction stormwater program, like we talked about today, you'd select construction activities. But if you wanted to access material regarding the industrial or MS4 stormwater programs, you could select those tabs instead. Clicking construction activities is going to present a set of 5 drop-downs. The first is background, and that includes a lot of the information that I talked about today. Next is construction general permits, where a copy of the permit is held. The technical assistant and permit compliance materials is where most of the general guidance documents are contained. If you're interested in the unique conditions of the Olentangy or Big Darty Creek watersheds, you could select those drop-downs for more specific information. The technical assistance drop-down is where you'll find the rainwater and land development manual, as well as many fact sheets and the spreadsheet tools. I highly encourage you to explore the page and find the various resources that work to improve understanding of the stormwater program in Ohio. So thank you so much for your attention. Here's a nice summary slide for who to contact in Ohio EPA Stormwater Program, depending on which question you might have. As you can see, we have technical assistant staff like me, permitting staff, administrative staff, and district staff, all at your disposal, ready to answer any questions you might have. I will note that there at the bottom, everyone in the agency has an email set up in the form firstname.lastname@epa.ohio.gov. So feel free to call or email. Well, thank you again for listening, but we got our last poll here. Hopefully the information that I talked about was information and useful. But what did you think? I learned something new. It refreshed my memory. It wasn't worth it. I fell asleep, or I can't wait to watch it again. Great. We don't have a lot of purple or yellows, which is where we were hoping to be. A lot of you seem to learn something new, or at least it refreshed your memory, which is a great thing. Keeping familiar with all the permit things are quite a process. So thank you. We'll take some time now for some questions.
All right. Thank you, Wes. We're now going to begin answering the questions submitted during today's presentation. As a reminder, you can still submit questions through the questions pane. We'll do our best to answer as many questions as possible. If we don't answer your question during the Q&A portion, we will reach out to you via email following today's webinar. So Wes, if you're ready, I'll begin with one of the first questions.
I am. Go ahead.
All right. So this question is, how long will it take for me to get my permit approved?
Oh, that is a very good question. I didn't really cover that very much. Well, the answer to that is, if everything in your NOI is submitted properly and completely electronically, then the approval process is honestly very fast. It's only going to take a day or so if everything checks out. if you mailed your check in the snail mail, then it's probably going to take a little bit longer, especially now because of the pandemic and a lot of our staff are working from home. But if in the event your application is incomplete, then the approval process can take much longer because we have to wait until it's submitted correctly. So let's see, some common issues that delay permit approval would include like missing payment. That's probably the most common. If there's no payment, then we're not going to approve the permit. If there's no site map has been submitted or it's inconsistent, like the area that's on the map doesn't mesh with the address or the coordinates that have been provided, then that would be another reason why the permit wouldn't be approved. Also, as I mentioned, if the consultant submits an NOI instead of the operator, then it will not be approved as it needs to be done by the operator. And lastly, another thing that I can think of is if the site has streams or wetlands on it that need authorization from our sister 401 program, then we're going to hold on to that permit until any 401 permitting has been resolved, because we really need to be able to work with our sister programs in the division.
All right. Thank you. All right. So this is a good question too. What information do I need to have on site that an Ohio EPA inspector will want to see?
You're right. That is a good question, Dan. When an inspector comes on site, they're likely going to walk around and visually inspect the site, but they're also going to want to see the information that you have on file. So most importantly, what they're going to be looking for is your SWIP and making sure that it's up to date and accurate. They're probably also going to look at your inspection reports to make sure inspections have been done and to see what any of your inspections have found. Also, they'll probably want to see the letter granting permit coverage. Some other things that they're probably going to specifically look for are just parts of the SWIP, but I guess I'll highlight them because it helps to be specific. So, for example, the logs that show grading and stabilization activities to see how things are happening on the site. The log that shows any SWIP amendments to see if the SWIP has been changed and what changes were made. And then the contractor acknowledgement form might be another one to make sure that all the staff on site have been made aware of the SWIP.
All right, Wes, it looks like we have time for one more question if we can get through it pretty quickly. I'm a consultant. Can I submit a permit application for my client? It's a good question.
Yeah, and no, I want to reinforce that. No, you cannot submit it for your client. You can fill out the NOI, you can fill out the application, but it needs to be designated to the client to submit. The operator needs to submit it.
And with that, we will end today's webinar. Thank you again for joining us and have a great day.